Hi friends, in this one I'm going to answer a question in math, but I'm going to use visual reasoning. So it's a bit of a story. Let's explore it together. Let's see what we discover. So take a look at the situation here. Imagine you have a triangle, and this is the vertical leg of the triangle. I'm going to call it A. So A, just some name. It doesn't matter what you name it. It's kind of important in math. Sometimes people think that names mean something. They don't. They're just symbols. I could call this B, I could call this C, I can call it whatever I want. It doesn't matter. It's just a symbol that we use to represent some object. Okay, and the name of the symbol that you use is made up. So I'll call it A. Now take a look. Here, this is the horizontal leg of the triangle right here. I'm going to call that one X. Again, nothing special about X, kind of important. You can call it whatever you want. You can call it Bob. Just call it something. And now, take a look at this last part. This is going to be the hypotenuse of the triangle, the pink line. By the Pythagorean theorem, hopefully you know that the following is true. That the length of this leg, like this, that would be equal to the a squared. So a squared here, that's a square there. And then let's see, plus the x squared. So in other words, plus, and then here you have x squared by the Pythagorean theorem, correct? So the x is this part and the a is this part right here. And in fact, just to focus on the x, I'm just going to write this in white too. There you go. So now here's a question I want to answer. And when you first see it, you might say, oh boy, how do we answer it? Take a look. So what I mean is, imagine you have the limit. So now I'm going to talk a little about calculus, but I'm going to find the answer to it not using calculus so much as just using visual reasoning. So hopefully in a way that anybody can understand. So limit as x approaches positive infinity. And then you're going to do the following. You're going to take the x from the horizontal leg and you're going to divide this by the following. By the length of the hypotenuse, which is a squared plus, let me focus on this, x squared this way. Keep in mind, this x is the same as this x. I want to know the value of this limit, right? This is equal to something. But the question is, what is the something? And now, if I had to work through this mathematically, it could be a bit challenging. So instead, I'm just going to try to find the answer using the picture alone. So how do we connect all of this to the picture, these symbols to the picture? There's a connection. The heart of it is right here, and focusing on this that says x is going to positive infinity. Really try to imagine what that says in terms of the picture. X is going to positive infinity. It's not just a kind of a dead static symbolism. It's telling you something about what's happening in the picture. So what is it? Take a look. Here is what's happening. Since x is going to positive infinity, you can imagine that x, the horizontal leg, it's doing this, right? It's getting ever bigger, ever bigger, ever bigger, ever bigger, ever bigger, like this. Because that's what it means to go to positive infinity. That means you get ever bigger. Now, what happens at the same time to the hypotenuse? That's what we want to know next. Well, the hypotenuse contains an x in this position, which means when x changes, the hypotenuse accordingly changes. In other words, it also gets stretched out. So in other words, the hypotenuse will do something like this. Look, see this? The hypotenuse is getting also bigger, 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 bigger until it kind of joins the leg at the very tip there, okay? Now look at these two lines very carefully. Look at the long pink line, look at the long blue line. If you measure these, you can pretty much tell that they're about the same length at this point because they're both so long. In other words, why do I want to know that? Because what it tells me is that the following is true, that the value of this limit is just 1. Why? Think about this. This just says the ratio of the blue leg, so the horizontal leg, to the length of the hypotenuse. But now, because they're both so long, they're about the same length, which means when you divide the length of one into the other, the ratio is 1 unit. That's all. So it's equal to 1. I've answered, in other words, this question by using visual reasoning rather than very formal mathematical calculus-based operations and all that. Having said that, though, would this still assist us in some fashion? Well, in other words, would the picture potentially still assist us in doing this a bit more formally? and not just kind of writing the answer down based on intuition about the lengths of lines. Well, let's try it. Let's see where that takes us. So the limit as x approaches positive infinity. So keep this in mind, right? This x here, it's this x, right? It's the length of this. And then you're going to have here x, let's see, divided by the square root of a squared plus, and then here, remember, this was x squared. So notice that it's x here and x here. Look at the picture carefully now. Relative to the length of x, which is this long blue line. A is a very small quantity, like this. This is A. X is probably 20, 30 times longer than A. I hope you can see that. Which means A squared relative to x squared is small. So what I mean is, imagine as an example, okay, that x has the value, let's see, make up a value, assign a value to x. Call it 100, like this. Then x squared, that would be 100 squared. Imagine A has the value 1. Then it would just be 1 squared as the value of A squared. 100 squared is much, much bigger than just 1 squared. And the picture confirms it. Make sure you really understand what this is saying. It's saying the blue leg is much longer than the vertical leg, than the A. So that means what we can do for that reason is we can drop this. We don't need that a squared when x is going towards infinity. Which means at the next stage, what is left over? Take a look. You're going to have the limit as x approaches positive infinity of, let's see here. So in the top you have this blue x. And in the bottom, the only thing left over now is this blue same x squared. Again, this x the same as this x, and now look very carefully at the last stage. What will happen with the root and the 2 in the exponent? Basic operation, you know that they cancel, which means what do you have left at the very end? Work through it. You're going to have the limit as x approaches positive infinity, and at the very end, what do we have left over? Think about it. Everything cancels. All that is left over is x over x, right? The blue x over the blue x. In other words, it's like saying, in the end, the only thing left over is the length of x divided by the length of x again. It's saying essentially because x has gotten so huge that the length of the hypotenuse, if you think about what this is saying really, the length of the hypotenuse is pretty much the same as the length of the leg labeled x. And of course, in the end, that is just equal to 1. And that matches this value obtained through visual reasoning. Now this value obtained through more formal manipulations, you get the same value in the end, in other words. That's all I wanted to say here. Thank you, friends. Please leave a like, please subscribe. I hope this has been interesting and insightful to you. Leave some comments down below. I'll see you in another video.